Okay, welcome back to Mr. Hassan's Maths channel. I'm answering now question number 15 from the February-March 2021 IGCSE Cambridge Paper 2 Variant 2 exam, and this question is about angles in circles. So it says here that points E, F, G and H all lie on this circle, okay, this circle here, and EG equals EH. So EG equals EH, so that means this is an isosceles triangle here. You can see that. It says ET is a tangent to the circle at E. That's a tangent to the circle at E. And angle FET equals 47. Okay, find the value of X. All right, there's a number of ways of doing this question, but what seems apparent to me is we're going to use what's called the alternate segment theorem. That's a very easy way of dealing with this question. So that states basically, and this is something that some students do have some issues with. So I'm going to try to explain it. So let's say we have a circle and we have a tangent to the circle. Okay, now that tangent, okay, when it meets a chord, for example, there's a chord that meets a tangent. So that's a chord in the circle, and that's the tangent in to the circle. So the tangent hits the chord at this point. Okay, that's where the tangent hits the chord. So the chord, touches the tangent at that point. Now, there's an angle that stands on this tangent. Okay, so if I draw a line from here on the other side of the circle, anywhere on the other side of the circle, and this angle here, it's standing on that chord which is touching the tangent. Now, the alternate segment theorem states that the angle between the tangent and the chord is equal to the angle that is standing on or subtended by that same chord on the opposite side of the circle. So this angle and this angle will be the same. Okay, these two angles will be equal to each other. All right, and we can kind of prove it in a way. I'll show you how we can prove it. And this is the proof. A lot of people, they don't know how to deal with this, but you can prove it by making like a angle to the center of the circle over here. All right, so this is like the radius. Okay, this is like the radius, and we know the tangent meets the radius at 90 degrees. Okay, so this angle, this is isosceles, this is isosceles. All right. So, for example, this angle here, this would be 90 minus this angle. So let's call this angle X. I'm just kind of proving it to you. In fact, you know what I'm going to do? I'm just going to use real numbers. Let's say this angle was, say, 40 degrees. Okay? In fact, make it look more realistic. Let's say this angle is 50 degrees. Okay, I'm trying to prove that this must also be 50. So if this is 50 and this is the tangent meeting the tangent meeting the radius, then these two angles must add up to 90, so this must be 40. And if this is 40, this must also be 40 because it's isosceles. This is the radius, this is the radius. And if these two are both 40, then this angle here must be 180 minus 80. 180 minus 40 plus 40. So that's 180 minus 80 is 100. And angles that are standing on the same, on the same arc. One of them is at the center, the other one's at the circumference. The one at the center is twice the one at the circumference, so this must be 50. This must be half of that. So we've proved that this angle is 50, therefore this angle is 50. That's kind of like a proof for it. But if you see the situation without even anything being drawn to the center, you should understand that this angle here between the tangent and the chord is always equal to the angle on the opposite side of the circle, which is standing on that same chord. So what we can see from here is you have, let me just highlight it, make it this highlighter a bit thinner. Okay, we have here this tangent meeting this chord. Now on this same chord stands this angle over here. Okay, so we can see that this angle 47 is the same as this angle here. because it's standing on the same chord. So this angle here is 47 degrees. Okay, we can say that, but even better than that actually is we can look at not this angle. Even better than that is we can think about this chord EG. This is even better. This chord EG here, okay, this chord meets the circle and meets the tangent at this angle over here. Okay, and this angle is 47 plus 25. That's going to be 60 plus 12. That's 72 degrees. The whole of the angle from there to there. All right, now on the same chord stands this angle over here. Okay, so let me just get rid of this. It stands the whole of this angle over here. Okay, so this whole angle here, this is the chord, this is the tangent, this is the chord. So this angle must be 72 degrees. Therefore, this angle must be 72 degrees because it's isosceles. Therefore, we can find what x is. This is one way of doing it. There's probably other ways as well, but this is what I can see. So therefore, we can say, so, I mean, if you want to show some reasoning, which is always a good thing, sometimes they'll ask you to, we can say that angle E, we can say TE, angle T, what am I doing? Angle TEG is equal to 25 degrees plus 47 degrees, which is 72 degrees. And we can say angle TEG is the same as angle TEG is the same as angle GHE. GHE, why? Alternate segment theorem. That's fine. You can just write that. That's fine. Okay. So therefore we can say GHE is equal to 72. And we can say also that angle HGE is also equal to 72 degrees. And you can just mention isosceles triangle. Therefore, x is equal to 180 minus 2 times 72. Okay, 180 minus 2 times 72. So we have 180 minus 2 times 72, which gives you 36 degrees. So x is 36 degrees. So we worked it out using the alternate segment theorem. As I said, there's lots of different ways of doing it. We could have, for example, worked out what this angle is. That's 47. And therefore, we could have worked out what this angle is plus this angle together. Because no, we couldn't actually. That's not isosceles. We couldn't say that. Okay. Well, we could have worked out. Let's see. Is there any other way of doing it? If we had worked out what this angle is, there's probably other ways of doing it, but I can't think of anything straight in my head. Straight away. Not really. No. Okay, there probably are other ways of doing it. Okay, angle standing on the same arc. Can we say that? For example, I could say that this angle is 25, therefore this angle is also 25 because they're both standing on the same arc. And if I know this is 25, does that help me anyway? Not really. Yeah, I think this is the only. There is probably other ways. Normally, there's lots of different ways with angles and circles, but the obvious way that seems to me the easiest way is using the alternate segment theorem. This is 72. This is 72. This is 72 as well because it's isosceles. Therefore, we can find x. Okay, so there's the answer to question number 15 from this paper. Other questions from this particular paper can be found in the playlist that will appear over here. Now, I don't normally answer every single question in a paper unless I am asked to do so. So I normally answer the questions by request, except for certain years, which I've done the whole papers. So if you find any question in this paper or any papers that you don't find in the playlist, and you'll see a link to my playlist for my IGCSE material in the description below. If you click on that link, okay, it will take you to the playlist where you'll see two different documents. One of them is a document which has all the years, all the past papers, the years. You can click on the link for the year that you want, and you can see if I've answered the question you want, fine. If I haven't, you can just send a comment on the YouTube channel, just on the comments, and just ask me if, for me to answer the question. And when I get time, I'll do so. And then you've also got another document which has the playlist according to topics. Okay, so you can click on a particular topic, and I've collected together all the questions I've answered on that topic in that playlist. That's why I answer questions one by one. I don't go through like all the questions in one go. I go one by one, make a video, so I can put the questions and classify them according to topic and paper. Anyway, so thank you for watching, and see you soon. So you'll see basically the playlist for this paper will be over here. The playlist for the topic of angles and circles will be over here. You can subscribe to my channel by clicking on this link, and if you watch the video that shows up over here, it will tell you how to navigate through my channel to find things that you want. Thank you for watching, and see you soon.